Okay. So let's look at a question like this. You can write it down if you like. I have a matrix A. I have a matrix A with elements. Please write them down so that if I clean, you can always refer to it. Let's say you have a 2 by 2 matrix A, -1, -1. You have another matrix A, B, also a 2 by 2 with elements 1, 4, X, Y. And they tell you that they tell you A plus B squared is equal A squared plus B squared. Then they go ahead to ask you to find X and Y. Who has an idea on how we have to go about this? We are doing some tutorial on matrix algebra. Anybody here who can help us, please? They have given you a matrix A and a matrix B. And there's an equation that says A plus B all squared and is equal to A squared plus B squared. Who can help us to do that? Hello. Okay, Emmanuel. Emmanuel, your hand is up. Please, if you are not supposed to talk, put your microphone on, else you are disturbing the whole class. Okay, Emmanuel, I'm listening.
All right, so first, I think we'll square. We'll multiply it by 8 times 2.
Who is the class talking?
8 times
I'm going
8.
to take him out of the class. That's what I do.
Go check it.
Hello, sir.
So go on. Kelvin, I've seen your question. Kelvin, I've seen your question.
Yes.
I think the class rep also sent it to me. Josephine was also asking me about that same question. So I think the only thing is you just go to, if you go online, maybe Google, then you type trig identities. To give you a lot of trig identities. From that trig identities, just look through them. Just as I told you the other time, that cos squared theta plus sin squared theta is equal to 1. There are other ones. You realize that one of them will help you to simplify that work. Kevin, are you okay?
Yes, please.
So you try it. Download all the trig identities, study them. You realize that there are some that can help you come to the answer. So try it. Josephine, you too. Josephine, that's why I have not answered your question. I want you guys to do it yourself, please. So let's go on. Reverend.
Yes, sir. Good morning, sir.
Chairman, how are you?
I'm doing good. I'm at your mercy.
So please, any idea about the question that I'm asking? Oh, so why can't
The chap said it's rude.
No wonder he's good like that.
Yeah.
all right, I'm listening.
I said no, sir. Now I'm waiting on you.
Oh, okay. Okay, so I sent a message that if you do not put your microphone off, I'll take you off. Okay, Emmanuel, talk. I'm listening.
All right, sir.
Yeah.
So,
Yeah, there are some of them.
I think since
Keep quiet, somebody need to.
Yes,
Some
Emmanuel,
guy.
please talk, okay?
He
okay,
asked you that.
please, I think since we'll
Take
be
explain that now you go do this.
we will need the square of A and then the square of B.
Okay.
In
That is the
our
right hand side of the equation.
Yes, please. So we can take the matrix of A and then square by itself so that
Yes. So
we can.
yes, that's what I understand you.
Okay.
Okay, so look at the right hand side. You're right. So if you look at the right hand side of the equation, it says what? A plus B all squared. So it simply means we should first add A and B. When we finish, whatever we get, we square it. So we are dealing with the right hand side. Now, when we add A and B, you all agree that we are going to get 2x minus 1, 6 y minus 1. Do you agree that when we add A and B, that's what we are going to do? When we finish, we have to square it. We have to square it. That means it has to multiply itself 2 times.
Okay.
Reverend, please, are you with me?
Yes, sir.
Okay,
Yes,
so
sir.
now
I'm
we
getting it.
are on the right hand side of the equation.
Yes, sir.
Okay.
Thank you.
So please, you have to be writing. Now, it means our right hand side will be equal. From there, you can see our right hand side is equal to what? 2, 6, x minus 1, y minus 1, multiplying itself again, square, the same thing. 2, 6, x minus 1, y minus 1. And we all remember our multiplication of matrices. We are supposed to apply it here. So each row in the first matrix is going to take all the columns. In the second matrix in the scalar dot fashion. So when we do that, what's going to happen? I'm going to have my first row taking the first row of the first matrix, which is 2x minus 1, taking on the first column.
Okay.
So this will take on the first column here. So 2 times 2, you all agree we are going to get 4.
4. Yes.
Then we add 6 when it multiplies x minus 1. So that's it. Then we go ahead. Then it multiplies the second column of the second matrix. That means 2 will multiply x minus 1 to give us 2 times x minus 1. Then we add we add the product that we get, that we are going to get from x minus 1 multiplying y minus 1. So that will be x minus 1 multiplying y minus 1. So that is the first row, taking on all the columns in the second matrix. Then we come to the case where the second row to do the same thing. The second row of the first one, taking on the sorry, please, I think I have to rewrite this. I didn't write it well. It's supposed to be this 2x minus 1 plus x minus 1 times y minus 1. This is how it's supposed to be. So the first row took on the first column of B, then. So please, this is how it's supposed to be. I interchanged it. I'm sorry. I hope you're okay. Nobody was able to alert me. So now the second row. So 2 multiplies 2. 6 multiplies 2, we get 12. Then we add y minus 1 multiplying 6, which is the same as 6 multiplying y minus 1. So now, second row has taken on the first column in the scalar dot fashion. Now we look at it, taking on the second column as well. So now, 6 will multiply x minus 1. Then we add y minus 1. Oh, who is this? Y minus 1 multiplying y minus 1. So we simplify. Now, what are we going to get on the first row? The first row, we are going to get 4 plus 6x minus 6. Then the other element there is going to be 2x
X minus 2.
minus 2.
Plus
Then we are going
X
to get xy. X multiplying y. Then x times negative 1 will give us negative x. So you have 2 brackets. The first bracket, every term in there is going to multiply every term in the second bracket. So x multiplies y in the second bracket. Then the same x multiplies negative 1 in the second bracket to give us negative x. Then in the first bracket, we look at the second term, which is negative 1. Negative 1 takes on minus y, positive y to give us minus y. The same negative 1 takes on negative 1 in the other one to give us positive 1. And we come to the second row. We are simplifying. We are going to get 12 plus
6y
6y
minus 6.
minus 6. Thank you. Then on the same second row, we have 6 multiplying x minus 1, which will give us 6x minus 6. Then on the other side, we are going to get plus y squared.
Plus
Are you following?
minus 1.
Minus y, and another minus y plus 1. Do you agree?
Yes.
Yes.
So what we are going to do is to simplify that up.
Sir,
So yes.
On the second row, is it x minus 1 into bracket x y minus 1, or is x minus 1? Why is it y minus 1?
You should look at the second row of the first matrix.
Yes,
Oh, that was the first row.
that was the first row, and you
Let's look at it. Let's look at
so
it.
it's supposed to be x minus 1, y minus, just like the y minus 1, y minus 1.
I don't think so. Look at it very well.
Yes,
so,
sir.
Let's look at it very well. That's first row taking on second column, isn't it? Please, are you with me? Hello, Reverend. Do you follow?
I've seen it now, sir.
You've seen it. So 2 takes on x minus 1, and x minus 1 takes on y minus 1.
Y minus 1. Yes, sir.
Okay. Okay. So I'm cleaning the upper part so that we continue. Now, let's simplify. So we are in effect going to get, do you see we are going to get 6x minus 2 on the first row, because you have plus 4 and minus 6. Please, you follow.
Yes, please.
Then let's look at the second element on the first row. We are going to have 2x. Look at it. I can see 2x. I can see minus x. That will reduce the x to just 1x. You agree?
Yeah.
And I can see
Yes.
plus x, y. Then I can see minus y. Then the constants, I have minus 2. I have positive 1. Minus 2 plus positive 1 will be minus 1. So that's the fact that the best simplification we can do for the first row. Now let's come to the second row. The second row, what's going to happen? We are going to have 6
X plus 6y
plus 6y. Okay. Then on the other side, we are going to have what are we going to have? We are going to have, there's only one term in x, 6x. There's no, the minus 2y. Do you see?
Yes.
Minus 2y. Then we can have plus y squared
Minus 5.
minus 5. So that's all we can do. So that's at the right hand side, which is the one that says a plus b squared. That's what it's going to be equal to. Please write it down. I might call for it later, please. Write it down so that when I come back to it, it wouldn't be a problem. Okay, so what's the left hand side also saying? The left hand side says a squared plus b squared. Please, sorry, I had a call. That's why I muted it. So that's the right answer. That means we'll be needing a squared, which you all know will be, our a was 1, 2, 1, 2, and -1, -1. So a squared will mean it will multiply itself 2 times. Who has been able to do that? What do you think that will be? Try it.
Yes, me.
You've done it, eh?
Mm.
Please try it. It's a tutorial. So I'm going to get this times that I get 2. So it's going to be 1 minus 2 for the first row. 1 times 1. First row multiplying first column. First row in the first matrix, taking on first column in the second matrix. 1 multiplies 1, we have 1. Plus -1 times 2. That will be 1 plus -2, which is 1 minus 2. Then the same first row takes on the second column. 1 multiplies -1, I get -1
1
plus -1 multiplying -1, so +1.
positive 1.
Then second row does the same. So second row takes on first column of the second matrix. 2 multiplies 1, we get 2.
2
Plus
Negative.
-1 multiplying 2, that would be -2.
-2.
So technically, it's going to be 2 minus 2, isn't it? 2 minus 2.
Yeah.
Then the same second row takes on the second column of the second matrix. So 2 multiplies -1, we get -2. Then 1 plus 1 multiplying -1 multiplying -1, we get +1. So finally, what would that be? Please write a squared down. We are going to get -1 on the first row, -1, 0. The second row, 0, -1. Please, do you see that? Hello?
Yes, sir.
Hi.
So write that down. A squared. We are getting a squared to finally be equal to -1, 0, 0, -1. Okay. So I'm cleaning. I want to, can I clean the board now? I want to look for b squared.
Yes, sir.
Yes, please.
Okay. So b squared will simply mean b multiplying itself 2 times. What was our b? 1, 4, x, y. Multiplying itself again. 1, 4, x, y. So what would this be? Our first row takes on all the other columns. So 1 multiplies 1, I have 1, plus x multiplying 4. You all agree that would be 4x. So what element will be, what will be the second element in the first row?
X plus 7x.
X plus 7x. Okay. X plus 7x. Is that so? No. Please look at it.
X plus XY.
Reverend, look at it too. 1 will multiply x. First element in the row will take first element in the column. So 1 times x, that will be x. Then x will multiply y to give us xy. Reverend, please, are you okay now?
Yes, sir. It was a typo. Why I wrote 7.
Okay. That's okay. So you agree that the second row is going to be. Please, you said?
X squared.
What is the x squared? Second row, second row, we are going to have 4 plus 4y. Where from the x squared?
Oh.
Huh? Second row, this second row, taking on the first column. 4 times 1, 4. plus y times 4, 4y.
Yeah.
So it takes the second column as well. 4 times x, we get 4x
Plus y.
plus y squared. Plus y squared.
Yes.
Okay, so that's okay. Remember that our a squared was -1, 0, 0, -1.
-1.
So now what will be our a squared plus b squared? You see that we are going to have 1 plus 4x
Into bracket.
plus -1. Do you see that?
No, can you go over it again?
Yes, sir.
You are adding
Yes,
b
sir.
squared. Look at b squared. Are
Please,
you
I'm
seeing the matrix? You are adding it to now the first element in A is -1. Then I add it to the first element in B, 1 plus 4x. First element in second element in row 1 of A squared is 0. When I add it to the corresponding one in B squared, it will be x plus xy. Do you agree?
Yeah.
When we come to adding elements in the second row, I'll add 0 to 4 plus 4y. It remains 4 plus 4y. Then I'm going to add -1 to 4x plus y squared. So that is the left-hand side. Please, are we okay? Please, are we okay?
We are okay. No.
Okay, so you have a squared already there. Okay, so I'm cleaning the board now. Please write down what we had for a squared plus b squared.
Yes, sir.
Write it down so that.
Yes, sir.
No, you can mute them. You can mute your mic.
Yes.
But boy, you can mute them.
Muted myself.
Okay, so the question said, a plus b squared should be equal a squared plus b squared. A squared plus b squared. Now, what did we get for a plus b squared? Please give me. First row, what's the first element in first row? Hello?
6x minus 2.
6x minus 2. I had a second element in that row.
X minus 1. X minus y.
X minus y and
Plus xy.
plus xy
Minus 1.
Yes, sir.
plus 1.
Minus 1, sorry.
Minus 1. Okay, then the second row.
6 plus 6y.
6 plus 6y.
Then 6x minus 2y.
6x minus 2y
Plus y squared minus 5.
plus y
Squared
squared
minus 5. Yeah.
Now that should be equal to a squared plus b squared, and that is the matrix. You agree that it will be equal to, if you look at the first element, -1 plus 1. Do you agree that will be 0? So we'll be left to 4x. Hello?
Yes.
Hi.
And the second one, then the second element there was x plus xy. And the second row was 4 plus 4y. Then the final row says -1
plus 4x Plus 4x.
Plus 4x plus y squared.
Yeah.
So now we have done what we, the right hand side we have computed it, the left hand side we have computed it, and they are saying the left is supposed to be equal to the right, and we have represented it very nicely. Then they say we should look for what? X and Y. Look at it. When you look at these two matrices that have been equated, what did we say about equal matrices? We said they have to be of the same size. Corresponding elements are also supposed to be what? Equal. If that is so, then it implies that to be smart, the smartest way to get my x and y is to equate 6x minus 2 to 4x.
Yeah.
Are you following?
Yes,
and
sir.
that would simply imply that 6x minus 4x is equal to positive 2. Do you agree? And
Yes,
if that
sir.
is true, then it implies that my x is what? 1.
1.
Because 6x minus 4x will be equal to 2. If I divide both sides by 2, I have x equal 1. Now that I have x to be 1, I can fix it into any of them and I'll get y. But the another smartest thing to do would be to say 6y plus, 6 plus 6y. First element in second row for the left-hand side. So when I was solving, I was calling the left-hand side the right-hand side, rather. It doesn't matter. It just know that. I can equate that to
4 plus 4.
I can 4 plus 4y. You don't have to go and choose any complex equations. Just do what will be simple for you. And that simply means 6y
minus 4y
will be equal what? 4 minus 6. You see that if that is so, we are going to get 2y equal what? Negative 2. So by solving that, our y will be equal to negative 1. Am I making sense?
Yes.
6 minus 4y will be positive 2y. Then when I go to the other side, 6 minus 2, 4 minus 6 will be the same as negative 2. So 2y will be equal to negative 2, and that means y will be negative 1. So we have solved the problem. I hope that's okay.
Which problem?
Who is that?
Which problem?
Please, any questions? Reverend, are you okay?
Yes, sir.
Okay.
Yes, sir.
Okay. Let's look at another one.
Okay.
Is this how your assessment questions are going to be like?
These are all questions that are possible that can come your way. Are you following?
Yes,
Because
please.
if you look at it technically, all the tools we use to solve this problem, addition of matrices, multiplication of matrices, equal matrices. These are the three things that we use to solve this problem. Because the left-hand side has to do with addition, a plus b. When you square, you are multiplying. The right-hand side has to do with squaring a and b, multiplication. When you finish, you add. Then after that, you have to equate the two. So you have all the tools to solve this problem. So it's a possible exam question, okay?
Yes, sir.
Okay. Okay. Now, if I ask you what is a matrix, what will you say?
It's an
When
array
I
of
ask you,
array of rectangular numbers.
okay, array of numbers arranged in a rectangular form.
You see them. Yeah.
Now, look at this question too. It says, let's see if somebody can do it and help us. It says what? If A is equal, if A is equal a matrix, I think a 3 by 3, 7, 3 minus 5, second row 0, 4, 2, third row 1, 5, 4. And it says and B is equal 3A, comma, C is equal B plus 2A minus 5I. Find D such that D is equal 2A plus B minus C. Please look at it and see if you have an idea.
Please, sir.
Yes, I'm listening.
We don't have something about I.
You remember I told you it's the identity matrix.
Identity matrix.
You remember?
Please, I didn't hear what you said.
He's saying nothing has been said about I. We have not been given I. And I'm telling you that I, if you remember, represents what? An identity metric.
Yeah.
And you know the identity metrics, you can have I2, I3, and so on. So the question is, which of them are we supposed to use? You know, the D that they are asking you to look for, you are adding and you are subtracting. And our rule for adding and subtracting was that the matrices are supposed to be of what? The same size. Do you remember?
Yes, yes.
So that means if we are working with an I, that means that I has to be I3. You get it?
Yes, yes, yes.
So I know the question knows you know what an I is. That's why I didn't mention it. Now, the D that you are looking for, it says 2A. 2 multiply matrix A. You already know A, isn't it? It has been given. Plus B. So let's say we are solving solution. To get my D, which they are asking me to look for, my D is 2A plus B minus C. So I first need to get my A, which has been given in the question. I'll need my B. But I don't have B. But I've been told that B is the same as 3 times the matrix A. So There, you have to know your scalar multiplication of matrices. So 3 is multiplying a matrix A. It means 3 will multiply every element in the matrix. So it means B will be equal to 21, 9, negative 15,
5,
0,
0, 12, 6.
12, and 6.
And
And my
6.
last,
Yes.
the last row is going to be 3,
15, 12.
15,
15, 12.
12. So that is the B.
Yeah.
So please write B down. You know what B is, write it down. Then we'll be looking for our C. Our C says what?
B plus 2A minus
And you know what
5.
2A will be? 2A will be 2 multiplying the whole of the matrix what? A.
A. Yes.
You follow the argument?
Yes.
Yes.
So please I clean what I have on the board now.
Oh, why
Yes,
not?
sir.
If you are writing, please write and let me clean it. So it means this time we will need our C.
Please, sir.
Yes.
But you see, the part we cannot find like literal expression first before calculate.
You cannot find what?
Literal expression, like we take the what's the name? The C, and we know that BA equal 3A. So we put 3A plus 2A, subtraction by 5I. Something like that. And now put the thing that the expression that we get there at the D. And now we get
that will also work.
Yeah.
You do substitution.
Yes.
So that he's saying this D is the same as 2A plus B minus B plus 2A minus 5I. So that you really have to look for C. Do you get what he's trying to say? But the substitution you are going to do for what I've underlined, the one in the bracket, will be the same as the C that you are looking for. Do you get what I'm trying to say?
Yes.
So it will all give you the same answer. I following?
Yes.
So I prefer to go by the way that I'm talking about. Or better still, if you like, you can do it like that.
All right.
Please, I hope you follow what he's trying to say.
Yes.
He's just putting the C in there. Please, I hope you've written A, you've written all the matrices down. I want to clean the board.
Okay.
So what will be the C that we are looking for? So our C will be equal B, which is you know your B.
Yeah.
9.
B is 9, negative 15.
0, 12,
6.
Then I have 3,
15,
and 12.
12.
And that should be plus 2. That means 2 multiply everything in A. What would that give us? Plus 2A. You know that simply means 2 multiplying everything in A. What we get? 14.
6.
14,
0, 8, 4,
14,
2, 10, 8.
14, 6.
14, 6.
Negative 10.
0, 8, 4.
8, 4.
0, 8, 10.
2,
2,
10,
2, 10, and 8. Correct.
Yes.
Minus 5I. Do you see that minus 5I will be 5?
5,
0, 0,
0,
0, 5,
5,
0,
0,
0,
0.
0, 5.
0, 5.
I hope you agree.
Yes, you agree.
So now the question is what will be our C? So all you do is you operate corresponding elements. Now elements in first row, first column are going to operate. The first one, the first element has element in first row, first column to be 21. Second matrix has it to be 14. The last matrix has it to be 5. So technically, we are talking about 21 plus 14.
14 plus 5.
Minus 5. What would that give us? 21 plus 14 will give us 35, isn't it?
Yes, so 30.
And 30 minus 5, we have 35 minus 5, we have 30. Then we have 9 plus 6, which is 15, isn't it?
Yeah.
9 plus 5, but 9 plus 6 will be 15, minus 5. That will be 10.
No.
Right. No, sorry, so minus 0.
Yes, 50
Yes.
minus,
Minus 0, thank you.
50 minus 0 is 15.
Then next we are going to have negative 15 plus negative 10. That will give us negative 25.
5
Minus 0, still negative 25.
25.
So let's come to the second row. Let's come to the second row.
0.
So do everything and just give me the values. All of you should try. So I'll be coming for the values for second row and that of the third row.
Don't do it.
It's going to be
So
So who can give me the second row, please?
0,
05, 015, 10.
0, 5.
0, 15, 10.
015, 10.
Okay, then the last row.
5, 25.
5, 15.
5,
25,
15.
7.
25, 15.
7. And 15.
So now I hope you can all look for your D.
Hey, 25 is 15.
Is it wrong?
No.
No.
It's correct.
Yes.
So your D says what? 2A plus B minus C. Please go ahead and do that and give us what you are going to get. At this point, I think everybody. So do that and let's see. You know what 2A will be, you know what B will be, you know what C will be.
B minus C.
Okay, it's going to give you
Huh?
5, 0, 0,
5, 0, 0,
0, 5, 0,
0, 5, 0,
0, 0.
0, 0, 5. Hello?
Yes, sir.
Yes, sir.
So it means we are going to get 5i.
Yes, sir.
Okay.
Please, my own is. Hello.
Your own is what?
Minus 5i.
Really? You had all the 5s in the leading diagonal to be negative.
Yeah.
Please, you hear what he's saying?
Please.
Reverend,
Yes, sir.
Yes,
do you
sir.
agree with him?
No, sir.
No.
So please, the guy getting the negative, go to your algebra work
All right.
and see. Because more than one person is confirming that this is the right one. I'm sure you have just interchanged some addition or subtraction. It's just a problem of the sign. Go through and see if you see the problem. You've seen it, eh?
I'm looking for it.
Just
So in fact, when you do the substitution, the first guy said, get 5.
so I'm sure the negative sign, if you did a substitution, that's why you have to put the C into the C into bracket.
Yes.
The negative sign must multiply everything in the bracket.
That's right.
So that's where you made a mistake. You have seen it, eh?
Yes.
So that's where the problem.
Yeah, it's true.
Okay.
Yeah. True.
So
Yes, so
okay.
it's I with the substitution.
Okay. So it's a 5i.
Yes.
Yeah. So let's see if we can do something on determinants.
So let's ask for the matrix.
Is that one?
No.
So I think we did determinants the last time. Okay, so were you able to solve that system of equations using the 3 by 3? No?
Yes.
I asked you to finish it. I hope you were able to do that.
Yeah.
Yes.
Okay. Now let's look at this. This you need to apply your determinants to be able to do this one. It says find x if who has an idea about this? What are they asking you to do? It says find the value of x if this is equal to that.
Yes, sir.
What do you think you have to do?
So 2b equals to 2x.
Is that one?
No,
2b equals to 2x.
this one we have to find the determinant first.
Thank you very much.
Yes.
The bar there is determinant.
Yes.
Saying the determinant of the matrix on the left-hand side is equal to the determinant on the right-hand side. So this simply means 2 times 1, you get 2 minus 5 times 4, 20.
20.
Should be equal to 2x squared minus 24. Now, you are looking for x, but your x is squared. Straight away, you know you are dealing with a quadratic equation.
Yes, sir.
So we are dealing with matrices has moved to quadratic equation. You know that the general form of a quadratic equation is ax squared plus bx plus c is equal 0. I hope you remember that.
Yes,
So
sir.
I need to do rearrangement and move everything to the other side of the equation. So I start moving. My left hand side, you know, or I can move 2 minus 20 on the left hand side. You know it will give you negative 18, isn't it?
Yeah.
So it means negative 18 will be equal to 2x squared minus 24.
Yeah.
Which is the same thing as, or if you like, negative 18 will be equal to 2x squared. In fact, this one is a quadratic, but we can even solve it straight away. Minus 24. When I move minus 24 to the other side, I'll get negative 18 plus 24 equal to x squared. Do you agree?
Yeah.
So the left hand side is going to be what?
6.
6. It's going to be 6.
Yeah.
When I divide both sides, so I'm going to get 6 equal to x squared. You see that implies that x is equal to 3. X squared is equal to 3.
So x equal to the root of 3.
So x equal the root of 3.
Yes.
So our x will be equal to root of 3. So what will be our final answer?
X is equal to
1.7.
Let's do it to 1 decimal place.
1.7.
1.7.
7.
Now, in an exam, if you leave your answer this way, I will not give you the full mark.
Why?
Why? Because once you are seeing squared, it should tell you that we are dealing with a quadratic function.
Plus or minus. Yes.
Thank you very much. We are going to have the other answer is going to be x equal minus 1.7. Please, who doesn't understand?
Me.
Now, what is the square root of 20? Sorry, 25.
5.
5.
5.
Why is the square root of 25 5? It's because 5 squared is what? 25.
5
Yes.
times 5 is equal to 25.
But you've forgotten that negative 5 squared is also 25.
Yes.
Exactly.
So at the lower level, you always think the square root of, say, 4 is positive 2. No. The square root of 4 is positive 2 and negative 2. Why? Because 2 squared is 4. Negative 2 squared is also 4.
Yes.
And that is why if you solve every quadratic equation, you get 2 answers. Do you understand? Okay.
Yes, sir.
Thank you very much. So your answer is plus or minus. Somebody will leave it as plus or minus root of 3. It's also correct. You understand?
yeah, there will be like that.
Is that one?
Sir,
Yes, please.
please, you see your first line.
My one?
Your first line, you multiply 2 by 1 and 5 by 4.
Yeah.
Please, why do you do 2 by 1 and 5 by 4?
And don't you see that it's a 2 by 2? And how to find the determinants of a 2 by 2? Do you remember?
Yes.
Elements in the leading diagonal will multiply. 2 multiply 1
Yeah.
minus the product of the elements in the other diagonal.
Mm-hmm.
You
Yes.
see, you are not learning. You are not learning. You see.
You are no, maybe does not eat. Maybe I come na dinner.
Oh. Anyway, a normal thing. Sometimes we forget the simple things.
Sure.
Mm.
What do you mean by that? Oh, sorry. I have to come. Yeah, it's not.
Some people are now entering the class. I don't know what they have been doing the whole day. We all knew we had a class this morning.
Yeah.
So I don't know what's happening. Anyway, those who just joined, we are just looking at some questions, tutorial questions. So Rep, I'm going to send you the questions so that you guys can go through some of them. Okay.
Okay.
So we'll be
meaning we are down for the day, right?
My friend. What? The next thing that we are going to look at is what inverses. Just as we saw the inverse of a 2 by 2, sorry, the determinant for a 2 by 2, determinant for a 3 by 3, and the inverses too, we are going to do same. Now, for the 3 by 3, it's a bit cumbersome. So I will just introduce you to the 2 by 2 today. Then when we meet next week in class, we go through the 3 by 3. Is that okay?
Yes, sir.
Thank you.
Okay, so let's look at the inverse of a 2 by 3 matrix. Now, so the first thing is, what is the inverse of a matrix? Now, if you remember the lower level, there's something we call the inverse of multiplication identity. When you say identity for the multiplication, now if I have the number 4, what will I multiply with 4 to maintain my 4? What will be that number? 1. Okay, so for multiplication, the identity is 1. Let's come to addition, and it's the same as division. So if I have 4, the only thing that will divide 4 by, the number that can divide 4 to give me my 4 back is 1. So for multiplication and division, the identity is what? 1. Now, what about addition and subtraction? What will I add to 4 or subtract from 4 to maintain my 4?
0.
0. So the identity for multiplication, addition and subtraction is 4. These are stuffs you know from the lower level.
Sir, is 0, not 4.
4 plus, yes, I know it's 0, yeah. So the identity for multiplication and division is 1.
4 plus 0 is 0.
And then 4 plus 0 is 4, please. So that is for identity. When we come to inverse for multiplication, if I have the number 4 and I want the inverse for multiplication, I'm looking for that thing that I'll multiply by 4 in order to get the identity for multiplication. You know the identity for multiplication is 1. Is that not it? Are you following? So for inverse, I'm looking for what to operate the number to maintain the number. Now, sorry, for identity, sorry. For inverse, I'm looking for the thing that will operate the number to give me identity. And who can tell me what that is? You don't know it. If you replace it with X,
1 over 4.
Your x will simply be 1 over 4. Because 4 times 1 over 4 is equal to what?
It's 1.
Is equal to 1. And that is what we call the inverse. So that is why sometimes this same 1 over 4 will be written as 4 to the power negative 1. Hello. So you see that 1 over 4 is the same as 4 to the power 1. And that is what we mean by the inverse. Bringing this knowledge.
Please, can you please start the explanation again?
I'm saying you understand the identity part.
Yeah.
Yes, sir.
Now, so you know that the identity for multiplication is 1, isn't it? Because if I multiply 4 by 1, I'll maintain 4. So identity for multiplication is 1. Now, if I have 4 and I'm multiplying it by x, and it's equal to 1, it means 4 times x, a certain number, is equal to the identity of multiplication. And 4 times x is 4x. If I solve that simple equation, I'm going to get 1 over 4. Do you agree with me?
Yes, sir.
And 1 over 4 from indices, we know that 1 over x is the same as x to the power negative 1.
Yeah.
Or if you like, 1 over x to the power n is the same as x to the power negative n. We know this from indices.
Yeah.
And that is what we call inverse. Now, let's bring this understanding to matrices. Are you following?
Yes,
if
sir.
I have A, what do I multiply? A matrix A, I want to multiply it by something to get the identity for multiplication.
The inverse.
Inverse, which is I. From what we have just done, that will simply be 1 over A. Do you agree with me?
Yes, sir.
And that 1 over A is the same as A to the power
Negative 1.
So the inverse of a matrix will always be denoted by the matrix to the power negative 1. So if I have a matrix B and I want its inverse is simply denoted or will be denoted by B to the power what? Negative 1.
Negative 1.
I hope that's okay.
Yes,
So
sir.
when I have a matrix, for example, I have a matrix B, and that matrix is a 2 by 2. Are you following? It means when I multiply that matrix B by its inverse, it's going to give me I2. Am I making sense?
Yes, sir.
So meaning you just interchange it, right?
You are?
You just change it, right?
You interchange what? I'm just saying if a matrix if I multiply a matrix by its inverse and I get the identity, then if the matrix is a 2 by 2, the identity that I'll get is a 2 by 2. If the matrix is a 3 by 3, then if you multiply it by its inverse, you get I3. Means the identity that you get will also be a 3 by 3. That's what I'm trying to say. I hope I'm making sense.
Yeah.
Okay.
Yeah,
So now let's
making
look at.
sense.
So now let's look at how we look for the inverse of a 2 by 2 matrix. This is the definition says the inverse of a matrix that is a 2 by 2 is simply equal to 1 over bar A, but that means the determinant multiplied by what we call the adjoint of the matrix we are dealing, which is A. So that's how you look for. So for example, you know that if I have A, and for example, A is a 2 by 2 with elements say A, B, C, and D. You all agree with me that the determinant of A will be equal A D minus BC. Do you agree?
Yes.
Now, the next thing you need will be the adjoint of A. When I write ADJ into bracket A means adjoint of A. Adjoint is spelled ADJ OINT. The adjoint of a 2 by 2 is simple. Look at it. This is what you do. you look at the matrix that was given to you. You switch or you interchange the elements in the leading diagonal. What are the elements in the leading diagonal? A and D.
A, D.
They swap positions. So this takes the position of A.
A takes the position of D.
And A takes the position of D. Then when you finish, you negate the elements in the other diagonal. That means the other diagonal, whose elements are B and C, you multiply them by -1 each. So B times -1, I get negative B. Are you following? And C times -1, I get negative C. And that is the adjoint of A. That is if you have a 2 by 2. So if I have a 2 by 2 matrix and I want its inverse, all I need is the determinant of the matrix and what the adjoint of the matrix. Please, is it okay? Can we go on?
Yes.
Can I see the board and look at an example? After the example, we can close.
Sir.
Now, let's take, say, this matrix C with elements 2, 5, 3, and say 4. If I want C inverse, I know my C inverse will be equal to 1 over determinant of C multiplied by adjoint of C. Now, you agree that my determinant is going to be 8 minus
3.
and that is what? -7. Do you agree?
Yes, sir.
So it means my C inverse is just going to be 1 over -7 multiplying what? The adjoint. How do I look for the adjoint? Elements in the leading diagonal interchange. So 4 and 2. Then I negate the other ones. -5, -3.
-3.
And you all know that this multiplication is simply what? Scalar multiplication. It means -1/7 will multiply everything in the matrix.
Yes, sir.
So my C inverse will be equal to -4/7. -4/7. +5/7. Do you agree?
Yes, sir.
+3/7.
Negative.
And then -2/7.
/7.
So when you have a 2 by 2 matrix, it is only the matrix that can change. The elements in the matrix, but the process is the same. So please try this. We are ending here, but try and see. Check if C times the multiplied by the C inverse that we have gotten is equal to I2. Okay? Investigate. Are you okay?
Yes, yes, yes.
Any questions? Any questions?
No questions, sir.
So, in the absence of no questions, we are going to end the meeting here. I hope that's okay.
Okay. Sir,
Thank
Yes.
you.
You there?
finding the determinant of a 3 by 2 matrix, you could help with that a small.
2 by 2 matrix.
No, 3 by 2. Determinant of a 3 by 2 matrix.
Remember, we said you can never find the determinant of a matrix that is not square.
I think he's not paying attention.
He doesn't come to class. I'm sure he doesn't.
Problem.
Yes. Please.
Please, the question I sent earlier, we had passed, was Ofori and I that solved the question.
I'll find the determinant of a 3 by 2 matrix.
We had passed the identity. Our problem ended after the identity.
The problem is after the identity.
Yeah. Like we were able to solve the identity part, but it was after the identity. So I wanted us to solve it together for that.
And then
I don't understand what
class,
you're
then
trying
say
to
we'll
do.
go over it. So let's go.
Okay,
yes,
you
they
what
can't
you
end
have
up.
done, what you have done so far, eh?
The boy is the best.
Person asking the question.
Yes, please.
What you have done so far, take pictures of it and send it to me on WhatsApp and let me see what you have done.
Yes, he doesn't come to class.
Okay, so we'll end here, okay?
All right.
Okay, see you guys. Bye bye.
Thank you.